Greetings and welcome. In today's video, we're talking about polar and rectangular coordinates. So we're trying to bridge a gap between basically the polar plane and the rectangular plane. So we're going to work kind of in both directions as well. So we're going to try to find some formulas that will allow us to convert from one form to the other, as well as eventually rewrite an equation in one form into the other form as well. So for starters, here's a point, just an arbitrary point that I picked in polar form. So if I know the radius out and the angle that I'm at, here would be r comma theta. So our question is, how could we find the x and y position of this point? And one of the ways we could do that, if I drop kind of a perpendicular line to the x-axis, my x would be the overness of the point and my y would be the kind of verticality of that point, right? So I'm essentially looking for this. I want to find the x and the y, right? But how can I find that x and y in respect to r and theta? And fortunately, we are all trig experts here, where I can just do kind of like a little right triangle trig here. So from theta's perspective, x is the adjacent and r is the hypotenuse. So I could say that cosine of theta is equal to x over r. So therefore, a little bit of work, I could end up finding that x is equal to r times cosine theta. And similarly, y from theta's perspective is the opposite leg. So, and comparing that to r, my hypotenuse, that would be the sine function. So in SOHCAHTOA, right? So sine of theta is going to equal y over r, and a little bit of work, I will get y equals r times sine of theta. And we've seen, I think, these relationships before. So, our first two kind of properties, I guess, if you will, or formulas. So converting from polar to rectangular, I can get x equals r cos theta and y equals r times sine theta. Alright, so those are our first little formulas that we've got for converting. So let's actually do an example here. So rewrite in rectangular form. So suppose I have this point, let's say I've got, let's make it 8 comma pi over 6, right? And so here is it in polar form, but for some reason I want to work in the rectangular coordinate system where it's going to be easier for us. So what I can do is just plug in what I know, solve for what I don't. Actually, it might not even be a bad idea to label what I know, r and theta. So let's plug it in. So x is going to equal 8 times the cosine of pi over 6, and y is going to equal 8 times the sine of pi over 6. So let's see. So cosine of pi over 6, pi is 180 degrees, dividing by 6, that's going to be 30, right? So cosine at 30 degrees is going to be, I believe, root 3 over 2. And sine at 30 degrees, or at pi over 6, is a half. So here I would end up with x equals, let's see, 8 and 2 can partially cancel, right? 2 goes into 2 once, and 8 4 times. So I'll get 4 roots of 3. And here, half of 8 is 4 for y. So my point is 4 square roots of 3 comma 4, right? And if for some reason it happened to be at an angle that wasn't one of the significant ones, I'd be able to get a decimal approximation and go from there. Right? So not terribly difficult. And then, I mean, we could even work in degrees if we had to. I guess I'll do a quick example. So what if I've got this point, negative 13 comma negative 70 degrees? So let's once again label our r is the negative 13. Theta is negative 70. And let's see, I'm going to be reaching for my calculator for this one, but we'll have to make sure we're in the correct quadrant here as well. Actually, it might not even be a bad idea. Usually always a good idea to draw a picture. So, oh, actually maybe it was better the first time. So let's see. So this point, if I go negative 70 degrees, is somewhere like this. And then they're asking me to move in the negative 13 direction, so it's the opposite right there. So I'm actually in quadrant 2 here, right? So that's worth knowing because I'm going to be finding out some values of sine and cosine in a moment. So x is equal to negative 13 times the cosine of negative 70. And y is going to equal negative 13 times the sine of negative 70. So reaching for my handy-dandy calculator here. Let's see, is this going to work correctly? I hope so. Let's see, I think so. So cosine of negative 70, I guess I should put it in degree mode, shouldn't I? I will get x equals negative 13 times 0.3420, little 4 decimal approximation is probably good, and y equals negative 13 times, now let's see, so sine of negative 70 will be negative 0.9397, right? So for x, I can get an approximation, multiplying that out, negative 13 times 0.3420, and I get about negative 4.446, and y, negative times a negative is positive, and I will get 12.2161. And I do want to point out that, right, x we were expecting to be negative, and y we were expecting to be positive. So this is the point, negative 4.446, comma 12.2161. So there's rectangular form of the same exact point. So that's how we convert from polar to rectangular. What about the other way around? Now this is a little bit trickier. I think I have enough room to fit it. Now in this case I'm actually going to need 2 examples. I'll try and explain my best to you why. So here, suppose I've got a point P x comma y, right? So I have the horizontal and vertical components of it, right? So x is the overness of that point and y is the vertical component of that point. And I know that they make a 90-degree angle. However, we are not interested in that. We are interested in what is the value of this r and what angle would this theta be with respect to those. So to find r, well, you might realize that we've got a right triangle. If I know 2 sides and I want the third, that sounds like classic Pythagorean theorem. So x squared plus y squared equals r squared. So r must equal the square root of x squared plus y squared. So there's our r value. Now to find theta, let's see, I know from theta's perspective here, y is the opposite and x is the adjacent. So I could say that tangent of theta would equal y over x, right? So theta is going to equal the tan inverse of y over x. And this is where I just need us to take into account which quadrants we're in. If you are automatically able to recognize which quadrant you're in and realize that this is going to give you some sort of a reference angle and figure it out from there, you'll be fine. But your book will have 2 separate forms for this. one in which we consider the value having a negative x. Right, so here's our x value, here's our y value. Because basically this tan inverse function, it's also called arctan, it has to have a restricted domain in order for it to be a function. Let me actually just draw a super quick sketch. So the tangent function looks something like this, right, going off forever in both directions. The inverse would be the flip of that. Let's see. So if this is tangent, the inverse would be something like this, right? So something like this. However, it would be going infinitely vertical in both directions, and that's not going to pass the vertical line test. So that's why they've decided to restrict it to just kind of one set of it, and they basically restrict it to quadrants 1 and 4. So anytime I'm in quadrants 2 or 3, I'm going to have to take into account that it's probably giving me the wrong theta value. And what we'll do in that case is just all I have to do is add pi to it, or 180 degrees, and it will end up working. So so let's see. So this one is for when x is greater than 0. Otherwise, theta is equal to tan inverse of y over x, and outside the parentheses, plus pi, or 180 degrees, whenever x is less than 0. And I guess, let's see, you're probably wondering why we didn't talk about when x is 0. You could probably determine which angle that is going to be. If x is 0, that means I'm on the y-axis. So my angle would have to be either pi over 2 or negative pi over 2 in those cases. So I guess that would be our third case. So let me write these down. Looks like I'm at the bottom of my page. So our 3 more facts, important ones to know. I'm writing in green in this case for whatever reason. R is equal to x squared plus y squared was our first one. And then we had theta is equal to the tan inverse of y over x. And theta is equal to the tan inverse of y over x plus pi on the outside for when x is less than 0. And theta is equal to plus or minus pi over 2, I guess. Oh, is that right? Yes. When x is 0. So this kind of takes care of all of these cases. So let's see. How am I doing for time? 13. I'm doing okay. Let's do an example. I was considering skipping this example, but I think we're okay. So suppose I have the point -8, -12, and I say to rewrite. Oh. Looks like I'm getting a little bit of lag here. In polar form. Right, so I know my x and y, might as well label that. And actually, x is negative, so I'm going to be using this version of the formula, right, for my theta when I get there. And let's figure out r first. So r is going to equal the square root of -8 all squared plus -12 all squared. It's really just the distance formula. Yeah, literally think of r as the radius of the circle. Square root of 64 plus 144. So r is going to equal the square root of 208. So r is approximately 208. And I get 14.4222, non-repeating. So there's our r. And then to find theta, since we've already determined we're using this version of the formula, we'll just do tan inverse, I like to call it, of y over x, so make sure you plug that in the right order. And like I said, drawing a picture of where this point is in the triangle will probably always be helpful, so it's not a bad idea to do that. Plus pi. And let's see, I'm going to have to remember to make sure I'm in radian mode again. So let's see, these minus signs will cancel out, so that's the same as tan inverse of, and actually 12 and 8 partially reduce as well, don't they? Let's see, 4 goes into 12 3 times and into 8 twice, and it's positive. And from this point on, the best I can hope for is an approximation. So tan inverse of 3 halves, I get 0.9828, and then I'm just going to do plus pi to that, and I will get 4.1244, and this is in radians. Right? So now I can represent this point as 14.4222 and 4.1244. And this is in polar form. And since I don't have the degree symbol here, it's actually implied that it will be in radians. So that's perfectly fine. So yeah, we can convert back and forth all day with these points, but what about when I have an equation? And that's where we'll have a little bit more work cut out for us. So let's rewrite in rectangular form. So suppose I've got the equation r equals 6 times cosine of theta. So here's the polar form of an equation. So this is probably some weird, well, we'd probably be able to figure that out if we wanted to. We could even graph that if you look at some of my previous videos. But I want to write this in rectangular form. So I could actually replace r with this if I wanted, or if I square both sides, I actually could have a modified version of this. I could say r squared is equal to x squared plus y squared. So that could help us out. What other fact do I know? Let's see, I think I've got the other facts written over here. X is equal to r cosine theta, y is equal to r sine theta. So if I could get an r in here, I'd be able to replace r cosine theta with x. So I think my first move is I'm going to multiply both sides by r. So I'll get r squared equals 6 times r cosine theta. So let's see, I've got some substitutions here that I can do. So r squared I can substitute, and r cos theta I can substitute. So I'll get r squared is replaced with x squared plus y squared equals 6, and r cos theta is going to be x. And it looks as though this is going to be some type of a circle that is offset. I guess I could write this in general form of a conic if I wanted. X squared minus, well, actually it would be plus y squared first, wouldn't it? Minus 6x equals 0. And then you could even go on to write that in standard form if you want to group the x's, complete the square, etc., etc. But yeah, so we're able to rewrite in rectangular form. And similarly, you can go in the other direction. This will be our last example for the video, and we're doing okay for time. So let's see, rewrite in polar form. So suppose I have the equation x minus 3 all squared plus y squared equals 9. So here looks like an equation of a circle, center at 3, 0, radius of 3. And I want this in polar form, so I don't want any x's and y's, I just want r's and thetas. So let's see what we've got. So I don't think I can use that necessarily. but I think I can use this. I'm going to replace x and y with each of their counterparts in polar form. It might be ugly, but let's see what we can do. Oh, it sounds like my son's a little upset in the other room. He's got a little bit of a fever tonight. I'll go check on him in a moment. So let's replace, as I said, the x and the y. And I will get x is replaced with r cos theta minus 3 all squared, plus y can be replaced by r sine theta all squared equals 9. So let's expand this out and simplify a little bit if we can. Over here I'm going to have to use this pattern a minus b all squared equals a squared minus 2ab plus b squared. And I will get, let's see, so a is the r cos theta part and b is the 3. Alright, so I'll get r squared cos squared theta minus 2 times r cos theta times b is 3, right? And then plus b squared, so that's plus 3 squared, which is 9. Squared here, so this would be plus r squared sine theta, or sine squared theta, sorry, equals 9. So let's see, I think I can, I've got some tricks I can do. I'm seeing a sine squared and a cosine squared, and I think I want those together. Perhaps you might recall a trig identity that will be helpful for us there. So r squared cos squared theta plus r squared sine squared theta. And I think it might be valuable for us. Actually, yeah, check this out. If I subtract this 9 from both sides, that will be 0. And I think I can also, this is looks like 6r cosine theta, so I'll add 6r cos theta to both sides. And let's see, so I've got, this is equal to, the 9's canceled out, 9's canceled out, 6r cos theta. And now here, if I had just sine squared plus cos squared, I'd be able to replace that with 1 using a trig identity, Pythagorean identity specifically. But it looks like the way I could get that is by factoring out this r squared. So r squared times, right, I'm even going to switch the order just so it looks super proper. Sine squared theta plus cosine squared theta equals 6r cos theta, right? And let's see, so this is equal to 1 using a trig identity, if I'm not mistaken. So I'll get r squared times 1 equals that, or just r squared equals 6r cos theta. And yeah, so I've got an equation that's kind of in that form. I guess would dividing by r, yeah, I think I can do that. Simplify here. Like so. I don't believe it will eliminate any answers in this case. But I end up with r is equal to 6 cosine theta. Alright, well thank you so much for watching, and I'll catch you guys next time.